All right, sometimes your teachers can be really mean. I have a number line here, and I can see it starts at 0, and the biggest number I can see it goes up to is 2. Now I've been given some decimals, which we're talking hundredths, some fractions, another decimal, we're talking tenths, another decimal, talking hundredths, a fraction, which is mixed, got a whole number and a fraction. Then I've got another decimal, we're talking hundredths, and then I have another fraction. To place these on this number line, you want to make them all the same, whether it's going with decimals or fractions. And looking at this, I can see we have 1, 2, 3, 4, 5, 6, 7 numbers we need to place on this number line. I'm leaning towards decimals. And the reason I'm saying decimals, I think it's a bit easier in my mind, because I know in my mind, for me, I can change the fractions easier to decimals. You might find it the other way. You might feel more comfortable with that. And if you know the relationship between 0.5 and a fraction, or a 0.25 and a fraction, that works as well. So in this case here, I have 7 numbers. What I would first do, I'm going to try and change this quarter, or any fractions, to a decimal. So a quarter, I know that's saying 1 piece out of 4, which looks like that. And I know, because I'm clever, on the back of this is a percentage. But if I move the decimal 2 places to the left, it's going to be 0.25. So this one now becomes 0.25. This one here, 0.80. We are talking hundredths. So this one, I'm talking hundredths as well. It comes to 0.5. Should I turn it to hundredths so that they're all the same? Let's try it. So this now, I'm going to rewrite as 0.50. This is in hundredths, so I can leave that one. 1 4/5. Again, this is where you need to understand equivalent fractions and decimals. I know 1 is 1 whole. 4/5. Now, if you're unsure how to sort of change these ones into decimals, here is a way you could do it. You can bring out your division. Got 4/5. So what I would want to do is I put the 5 on the outside, and the 4, which is the numerator, goes inside. So denominator outside, numerator inside. In this case, normally I've got 4. Can I divide that by 5? Not really. But because of the use of decimals, this is the way you do it. 5 can't fit into 4, so I put a 0. Then I put a decimal point, because 5 cannot fit into 4, not evenly. And now the next step, I place a 0 here. Now, can 5 fit into 40, or 40 divided by 5? Sometimes the teachers say it different ways. 5 can fit into 40, or 40 divided by 5 is, this is where your times table and division come in handy, 8. And I've got them all lined up. 8 times 5 is 40, nothing left over. Now, 0.8. I know I had a 1 here. So I'm going to have to rewrite this as 1 whole, because that's the whole number, decimal point, and the 8. And the other thing I want to add to this is a 0. Because I'm trying to make them all either tenths or all hundredths. But obviously, because I've already got hundredths, I'm going to try and convert them all to hundredths. So that one there is what you do to create this one. I'll just show you back here. We had 1/4. Okay. So again, here's my. Which one goes where? numerator goes denominator on the outside. 4 cannot fit into 1, so I put a 0. Then I put a decimal point. Next thing is I put a 0, which is the placeholder here. Can 4 fit into 10? It can. Not evenly. How many? 2. 2 times 4 is 8. Do a minus. 10 minus 8 leaves 2. Can 4 fit into 2? No. So again, this is where I put another 0 on the end. I'll just do that. I'll pretend 0. Now, can 4 fit into 20? It can. 5 times. 5 times 4 is 20. That's where we've got the 0.25. Okay, so that's, just to show you that, that's the way you do it. And that's already got my hundredths, so that one's fine. So these ones, again, you can always come back, rewatch this video to check that out. 0.08, that's fine because we are dealing with hundredths, it's fine. And the last one, 3 out of 3. I've got something that looks like this, and it's all there. So 3 out of 3 equals 1 whole. Now, I can put 1.00 or 1. It's going to be the same. Now I've got all these. I have 0.80, 0.25, 0.50, 1.25, 1.80. I can see any numbers that have got 1 point something, these two, or this one here, the third one is 1. Now I can place them where I think they are on the number line. If I divide this into 100, each one. First thing I do though, I have 0 and 2. What would go in here and why? For those people who thought, well, you put that 0.5 because that's the same as a half goes here. Would that be correct? I can understand why somebody would say that. It's not correct because what would you do if it was 1.5? So we'll come back to that one. We know the easiest one would be 1, but 0, 2, this has to be 1 here. So that's 1. So that one, 3 threes, or 3 thirds, would go here, because that's equal to 1. Happy with that? Yeah. Next one I might do, 0.5. If it's not there, that must mean half, or 0.5, is between 0 and 1. Again, I could cut it up into 100 pieces here, or 10, because that 0 is just the place value. I would say halfway would be about here. So that's where I put 0.5. And again, it's really, that is the same as that. So, yep, happy with that one. Next one, a quarter. And I know the relationship between a quarter and a half. So a quarter is half of a half. So 0.25 is half of this one. So again, I find halfway between 0.5, I'd say be about here. 0.25, which is a quarter. And I say, yeah, that looks pretty good to me. But because I had it in this one here, I'd actually then have to go back and change this to a quarter, because that's what they really want you to put in there. That's the quarter. Again, you might underneath put 0.25. Teachers are happy if you do that. It shows that you understand. So whatever is here originally is what you actually want on the number line. Anything else to help you, put in there, absolutely. Next one, I might go with 0.8, or 0.80 actually it is. So between 0 and 1, I'd have to slice it into 80 pieces. But I know if I do 8 tenths, I cut into 10 bits. And, oh, what's going on here? Get rid of that. So if I did that, if that's half, that'd be about 6, 7, 8, 9. So 8 must be about here. So that here would be 0.80 because of they had the hundredths. I'll put that there. So, yep, done the quarter, done that. 1.25, we know the 1 is 1 whole, so it's got to be after 1. The 0.25, if I look back here, it's the same as a quarter. So find halfway here, then half it again. Or I could cut it into tenths. So here would be 1.25. This one here would have to be 1.5, but I don't have any 1.5s. I do have a 1 and 4/5. Same situation, I can relate it back to this one, it will help me out. So this 0.80 is here. So again, be a little bit shorter than that one, would be here. But again, you'd have to sort of measure out properly. 1.5, if I cut that about 1.75, that's 1.75. So I'm just putting these to help me. Yep, 1.8, maybe a little bit back this way, maybe about there. 1.80. Happy with that one, happy with that one. Which brings us to 0.08. So the 0, there's no whole numbers, no ones, and it's telling me there's 8 out of 100. So this is the part where I can see here I've got 0.25. So if that's 0.25, 0.08 is going to be before it, but whereabouts? It's a bit like saying this from here to here has been sliced up into 100 bits. Now if I find if this roughly is 25 bits, this is 50 bits, this one between here would be 75 bits, that one would be 100 bits. So about, what's half of 25 roughly? About 12 and a half. So 12 would be about here. 10 might be about here. So 8 must be round about here, give or take. So I would say 0.08 would be here. Now, if you can understand that, you've done really well. But again, stop the video, go back, re-watch how Miss Blair has done that. It is tricky, but this is what you're now facing.